Today we're diving into something that might blow your mind, literally huge numbers in Java. Have you ever wondered what happens when regular integers and doubles just aren't big enough? What if you need to calculate numbers so massive they'd make your calculator cry? Well, Java has got you covered with big numbers. Let me ask you this, what's the biggest number you can store in a regular Java int? Anyone? That's right, about 2.1 billion, and for a long, about 9 quintillion. Sounds big, right? Well, what if I told you we're going to calculate factorials that result in numbers with dozens of digits? Numbers so big that regular data types would just overflow and give you completely wrong answers. Enter Java's superhero classes BigInteger and BigDecimal, living in the java.math package. Think of them as the Hulk version of regular numbers. They can grow as big as your computer's memory allows. BigInteger handles whole numbers with arbitrary precision, meaning unlimited digits. BigDecimal does the same thing but for decimal numbers. No more overflow errors, no more precision loss. First things first, we need to import java.math to access these powerhouses. Now here's the thing, you can't just write BigInteger my number is equal to 100. Nope, we need to use special methods to create these big numbers. Let's start with the basics. For regular-sized numbers, we use the valueOf method. But what about really big numbers? Numbers so big they can't even fit in a long, that's where the string constructor comes in. Look at that monster, 60 digits of pure numerical power. Try storing that in a regular int, I dare you. Imports all classes from java.math so you can use BigInteger without specifying full package name. Blank line for readability. Declares public class blank line for readability. Declares public class basic BigInteger creation. Defines the main method, the entry point of a Java application. Creates a BigInteger with value 100 using valueOf method. Prints BigInteger to console. Closes the main method. Closes the class definition. Comment describing the next code segment. Java also gives us some handy constants. We've got BigInteger.0, BigInteger.1, BigInteger.10, and since Java 9 we even have BigInteger.2. Pretty convenient, right? Now here comes the plot twist that trips up many developers. You cannot use regular math operators with BigInteger. This won't work. Instead, we need to use methods. It's like learning a new language for math. I know, it looks weird at first, but think of it this way, these objects are doing incredibly complex calculations behind the scenes. They need these special methods to handle all that complexity. Imports all classes from java.math package, allowing use of BigInteger and related utilities. Declares the public class BigInteger operations. Main method's starting point of execution. Initializes BigInteger A with value 100. Initializes BigInteger B with value 50. Comment illustrates invalid BigInteger arithmetic with plus operator. Example that would fail, BigInteger result equals a plus B. Adds in B via add and stores in C. Prints result of addition. Calculates D as C multiplied by B plus 2. Prints result of complex multiplication. Subtracts B from A. Prints subtraction result. Multiplies N B. Prints multiplication result. Divides A by B. Prints division result. Calculates A mod B. Prints modulus result. Ends main method. Ends BigInteger operations class. Let's see BigInteger in action with something simple but powerful: calculating factorials. You remember factorials from math class, right? 5 factorial is equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 is equal to 120. But what about 50 factorial or 100 factorial? Those numbers get huge fast and regular data types just can't handle them. Let me show you a simple factorial calculator using BigInteger. Let's walk through this step by step. We start with BigInteger.1, which is 1. We loop from 1 to n each time. We multiply our factorial by the current number using the multiply method. Finally, we print the massive result. Try calculating 50 factorial. You'll get a number with 65 digits. Compare that to what a regular long would give you. It would just overflow and give you a completely wrong answer. Imports BigInteger class from java.math package for handling large integer values. Import scanner class for reading user input from console. Declares the public class factorial calculator. Main method where program execution begins. Creates a scanner object to read user input from standard input. Displays message prompting the user to enter a number for factorial calculation. Reads the integer entered by the user and stores it in variable n. Initializes BigInteger variable factorial to value 1. Multiply. For loop iterates from 1 to n, multiplying factorial by current value of I. Multiplies current factorial by I and updates the factorial variable. Closes the for loop. Prints the result in the format n equals factorial. Closes the main method. Closes the factorial calculator class. BigInteger comes loaded with methods for every math operation you can think of. Let's do a quick tour. Add, subtract, multiply, divide, your basic arithmetic. Mod for remainder operations. SQRT for square roots, added in Java 9. Comparator for comparing big integers, returns negative, 0, or positive. and our friend valueOf for creating BigInteger from regular numbers. Imports all classes from java.math package, giving access to BigInteger and its methods. Declares public class BigInteger methods demo. Main method where program execution starts. Initializes A equals 100. Initializes B equals 50. Initializes C equals 25. Prints header text. Prints a B C values. Prints a B. Prints a blank line. Prints addition result. Prints subtraction result. Prints multiplication result. Prints division result. Prints modulus result of a mod B. Initializes big number equals 144 for prints square root of big number. Calculates. Compares and B returns positive a B. Compares B and A returns negative B, A. Compares B and B returns 0 equal. Initializes long value with large number. Converts long value to BigInteger via valueOf. Prints converted value. Initializes base equals 2. Sets exponent to 10. Calculates base exponent. Prints power result. Initializes negative equals. Prints abs negative. Prints maximum of NB. Prints minimum of NB. Initializes huge number from string. Prints huge number. Prints number of digits in huge. Ends main method. Ends BigInteger methods demo. Ends main method. Now let's talk about BigDecimal, BigInteger's decimal-loving cousin. It works similarly, but handles decimal precision like a champion. The methods are almost identical: add, subtract, multiply, but here, where it gets interesting with divide. The first divide method can throw an exception if the result doesn't have a finite decimal expansion. Think dividing 1 by 3, it goes on forever. That's why we have the second version with rounding mode. Half UP is the rounding you learned in school: round down 0.4, round up 5.9. From java.math package. Imports all classes from java.math package. Declares the BigDecimal operations public class. Starts the main method program entry point. Creates BigDecimal variable A with value 100.5. Creates BigDecimal variable B with value 25.3. Adds A and B and stores result in sum. Prints the sum of A and B. Subtracts B from A, stores in difference. Prints the difference of A and B. Multiplies it by B, stores in product. Prints the product of A and B. Comment division example. Performs division of A by B. Prints the division result. Catch. Prints error message on division failure. Performs safe division of A by B rounded half UP. Prints safe division result. Creates BigDecimal from integer 100. Creates scaled BigDecimal value 1. Prints heading for creation methods. Prints simple created value. Prints scaled created value. Creates BigDecimal value 1. Creates BigDecimal value 3. Attempts to divide 1 by 3 will fail without rounding. Attempts to divide 1 by 3 will fail without rounding. Prints error message on failed division. Divides 1 by 3 with 10 decimal places and half up rounding. Prints properly rounded division result. Before we wrap up, here are some pro tips. Use valueOf for numbers that fit in a long, it's more efficient. Use string constructors for truly massive numbers. Remember, no regular operators, always use methods. Big decimal division can be tricky, always consider rounding modes. These operations are slower than primitive types, use them when you actually need the precision. Think of BigInteger and BigDecimal as precision tools. You wouldn't use a surgical scalpel to chop vegetables, right? And there you have it, Java's big numbers. From calculating massive factorials to handling financial calculations that demand perfect precision, BigInteger and BigDecimal are your go-to tools when regular numbers just aren't enough. If this helped you tackle those massive numerical challenges, smash that like button, subscribe for more Java deep dives.